Yes, guys. So we are doing types of matrices, in which I was discussing about 14th type. Okay, this I left it in between because of lack of space. Now come to the point. Now 14th, which is periodic matrix. What is a periodic matrix? I defined it. Let me again define it. A square matrix that we write here, or let me define it here. A square matrix. Let me take A is said to be a periodic matrix. Is said to be a periodic matrix of order. Let me take of order k. K are taken a constant. A square matrix A is said to be a periodic matrix of order k if A raised power k plus 1 is equal to A. Okay, so this is, and I talked about idempotent matrix, in which we discussed that if A square is equal to A, then A matrix is known to be idempotent matrix. Okay, so in this case, if I write k is equal to 1, where k is a positive integer, is a least positive integer or positive integer, where k is a positive integer. Now positive integer, if I take least positive integer, then it will become an idempotent matrix. If k is a least positive integer, the least, let me take the least positive integer, then a to a square equal to a, that means a raised power 1 plus 1 is equal to a. Here k will be then 1, imply that k is equal to 1. In this case, p will be 1. In case of this, in that situation, the matrix is known as idempotent matrix. So, idempotent matrix, as I tell you, that idempotent matrix I have defined already. Idempotent matrix has a periodic matrix, or is a periodic matrix of order 1, k is equal to 1, of order k is equal to 1. Now if I take AQ here and AQ turn to be A, then order will be 2, k is equal to 2. If A3 is equal to A, that means A raised power 2 plus 1 is equal to A, or k is equal to 2. In that situation, period will be 2. In that situation, k is 2 if AQ is equal to A. I'll take one instance here of AQ equal to A, okay, and I'll just talk about that how it is equal to A. Okay, after multiplication, we have to know what the multiplication of matrices are defined. That I have already introduced that. Okay, previously in case of singular matrices, I talked about if determinant of value is 1. Okay, periodic matrix. Okay, before that, self-reciprocal matrix are also defined. Involuntary matrix, nilpotent matrix, and okay, so symmetric matrix. All these are defined already. In case of multiplication, if I find conjugate or transpose conjugate of a matrix, self-reciprocal matrix, it is that inverse of a matrix is to be calculated. Okay, so inverse of matrix, when I am defining here adjoint of matrix, okay, so multiplication also I have defined previously. Okay, so that is in case of idempotent matrix. This is the idempotent matrix. In idempotent matrix, A square equal to A I defined, and multiplication also I defined. So how to multiply two matrices of conformable matrix? I mean, they are conformable matrices, means they have the number of columns of first matrix is equal to number of rows of the second matrix. Only then they are conformable, they can be multiplied. So multiplication of matrices are defined here in case of idempotent matrix. Now in in 13th number, okay, now I'm defining periodic matrix. So idempotent matrix is a part of periodic matrix. In this case, period is 1 in case of idempotent matrix because K is 1, 1 plus 1. Here A 1 plus 1 equal to A. In that situation, so K is 1 in place of K. We have seen here. If AK plus 1 is equal to A, that means K is 1 in case of idempotent matrix. So 13th is also involved in this. Now let me take here K is equal to 2 in case of AQ equal to A. Now let me take, instance here, one instance of AQ, so that it can be defined easily. What is periodic matrix that I'm defining? If let me take A is equal to a matrix minus 1, 3, 2, minus 2, or 0, 2, let me just think about what is that. Minus 2, 2, 0, minus 2, 2, 0, this is minus 6, 9, and minus 3. Okay, let me just think about whether this is coming of the same type or not. Okay, so that is the point here. 1 minus 3, this is, sorry, 1 minus 3, if I take, only then it will be possible. 1 minus 3, 2, minus 2 and 2 and 0, minus 2, 2 and 0, and minus 6 and 9 and minus 3. Okay, now in this case we will find that AQ is equal to, okay, in this AQ is equal to A, so period will be here, or okay, here if I find out AQ, let me first find A square, then AQ we will find out what is A square, this multiplied with this. Okay, then AQ we will calculate, it will be A then. So in this situation, AQ is equal to A. In this instance or in this example I have taken, A is equal to 1 minus 3, 2, minus 2, 2, 0, minus 6, 9, and minus 3. If I solve it, if I find out multiplication of this 3 times, A into A into A, that is first find out A into A, okay, A square then, and whatever comes out, then that value into again A, that will give us A, the matrix itself. In this situation, A square, that means A square plus 1, A2 plus 1 is equal to A. Here K is 1, this implies that A is equal to 2, sorry. K is equal to 2 here, so period of this matrix. This is now periodic matrix. Here period is 2, here period is 2. Period is 2. Okay, so because K is equal to 2 here. This is periodic matrix, but before that, let me just prove it, that how this is possible. So let me just multiply this and just find out, so that you can understand that what is the proper value of this. So A into A, first I am finding out A square. What is A square of this? So let me just multiply. This is 1, minus 3, 2, this is minus 2, 2, 0, and this is minus 6, 9, and minus 3. Then again multiply this 1 minus 3, 2, this is minus 2, 2, 0, this is minus 6, 9, and minus 3. Okay, what is the result of this, resultant of this for me? So that let me multiply. So first row, multiply to first column, second column, third column. 3 elements will be obtained by corresponding multiplication. I am just doing this very fast so that the time can be taken. Okay, time is not taken. Now this 1 into 1 is 1, minus 2 into minus 3 is plus 6. We have to add all the corresponding multiplication of these 3 elements with these 3 elements correspondingly. 1 into this, 2 into this, minus 6 into minus 2, sorry, plus 2, this is minus 12 here, minus 6 to 12, minus 2 into minus 3 is plus 6. Okay, so this is the first element. Then this first row is multiplied with second column. Second column is 1 into minus 2 is minus 2, minus 2 into plus 2 is minus 4, and minus 6 into 0 is 0. Okay, so it is 0 here. Okay, next, first row multiplied with third column, it will give us 1 into this is 1 into minus 6, this is minus 6 here, minus 2 into 9 is minus 18, minus 6 into minus 3 is plus 18. Okay, this is plus 18 here. Is first row is completed. Now second row, if I multiply, I have to multiply by second row now. Second row, if I multiply the first column, so minus 3 into 1 is minus 3, 2 into minus 3 is minus 6, 9 into 2 is plus 18. Alright, again second column, second row multiplied with second column now, then it will give us second element of the second row of the resultant matrix. Okay, so it is now minus 3 into minus 2 is plus 6, 2 into 2 is plus 4, 9 into 0 is 0, plus 0, this is plus 0 also. Okay, then second row multiplied with third column, this is minus 3 into minus 6 is plus 18. Okay, 2 into 9 is plus 18, 9 into minus 3 is minus 27, 9 to 27. Again, third row multiplied correspondingly first column, second column, third column. What does it give us? It will give us, let me just, under 2 into 1 is 2, 0 into 3 is 0, plus is 0, minus 3 into 2 is minus 6. Okay, now third row multiplied second column, 2 into minus 2 is minus 4, 0 into 2 is 0, minus 3 into 0 is 0. Okay, then third row multiplied with third column, correspondingly 2 into minus 6 is minus 12, 0 into 9 is 0, minus 3 into minus 3 is plus 9. Okay, this is the value here. Now let me take this here. So what the result A square is, then what? Let me just put it here. Okay, so A square comes out to be 6 plus 1 7, and minus 12 is minus 5. It is minus 5 here. Minus 12 plus 7 is minus 5. Okay, this is minus 6 here. Minus 2 minus 4. And 18 plus 18 cancelled out. It is minus 6 only. Okay, then minus 3 and minus 3, minus 6 and minus 3 is minus 9, and plus 18 is plus 9. 6 plus 4 is 10. Okay, then 18 plus 18 and 27, 27 and minus 27 plus 9 is only, but 36 minus 27 is plus 9. Okay, then 2 plus minus 6 is minus 4. Minus 4 is again, this is minus 12 plus 9 is minus 3. This is the value of A square. Now if I multiply this with A again, with A, that will again multiply this. Then now A cube therefore is equal to, I have to multiply this by A again. This is A 1 minus 3, this is 2 here. So minus 2, 2 0, this is minus 6 9 and minus 3. So corresponding again multiplying. Let me just check whether it comes out to be A or not. Okay, so this first row multiplied to first column. This is 1 into minus 5. That means right here this is minus 5 here. Minus 6 into minus 3 plus 18. Plus 18. Okay. Minus 2 and 2 is minus 12. Alright, so this is 1 comes out to be, because minus 5 minus 12 is minus 17 and plus 18 is 1. 1 is coming here. Alright. Then first row multiplied with second column correspondingly. Minus 5 minus 2 is plus 10. Minus 6 and 2 is minus 12. Right. Minus 6 and 0 is 0. It is minus 2, it comes out. It is minus 2. Minus 12 plus 10 is minus 2. Minus 2 is there. A, it is comes out to be A. Okay, let me take again. So first row multiplied with third column will give us third element of the first row. So this is minus 5 minus 6 plus 30. Alright, minus 6 and 9, 9 6 is 54, minus 54, 6 into this is plus 18, 6 3 is 18 plus 18, 18 plus 30 is how much? 48. 48 and minus 54 is minus 6. Alright. Is coming out. Minus 6 is coming out. No problem. Again, now second row multiply to the corresponding columns here. First column, 9 into 1 is 9. 10 into minus 3 is minus 30. 9 into 2 is plus 18. Alright. Let me again multiply second row, second column. So 9 minus 2 is minus 18. 10 is 10 into 2 is plus 20. 9 into 0 is plus 0. Alright. Nothing else. Next, second row multiply to third column. It will give us third element of second row. It will give us 9 into 6 is minus 54. 10 into 9 is plus 90. Alright. 9 into minus 3 is minus 27. Okay. So the difference will come out to be 9. Alright. Because if I take 9 here, 36 plus 54 will be 90. Alright. This difference is 9. Now, third row, let me multiply by third row, two columns, first column, second column, third column. So first, third row, let me multiply by third row to first column. So it is minus 4 into minus 1, sorry, plus 1 is minus 4, minus 4 into minus 3 is plus 12, alright, minus 3 into 2 is plus 6, sorry, minus 6. Well, it is minus 3 into 2 is minus 6, sorry. Then third row multiplied to second column correspondingly. Minus 4 into minus 2 is plus 8. Minus 4 into 2 is minus 8. Minus 3 in 0 is plus 0. Minus 0 or plus, it doesn't matter. It is 0 only, minus 0. Okay, then third row multiplied to third column. It is minus 4 into minus 6 is plus 24. Alright, minus 4 into 9 is minus 9 for your 36. Okay. Minus 3 into minus 3 is plus 9. Now let me find out the resultant of this. What is the result of this? Finally, AQ comes out to be, what is that? Is it coming A or not? Now here, 18 plus 18 minus 17 is plus 1 difference. 10 plus 10 minus 12 is minus 2. Alright. 30 and 18, as I did tell you, 48 and minus 54 is minus 6. Alright. Then 9 plus 18, 27, minus 30 minus 3, difference is okay. Then 18 and minus 18 plus 20 is plus 2. Okay, minus 54 minus 27 is 7 plus 4, 1. Okay, 7 plus 4, 11 and 1 carry. 5 plus 2, 7 and 1, 8, 81. It is minus 81 and plus 90. That means difference is 9. Difference is 9 here. Okay. Then minus 6 and minus 4 is minus 10 plus 12 means plus 2. Plus 2 is coming. Okay, now here in case of this minus 8 and plus 8 is 0. It is 0 here. And 24 plus 9 is how much? 6 plus 33. 33 and minus 36 is minus 3 difference. Minus 3 difference. A, it is A only. Undoubtedly. So this is a periodic matrix of period K is equal to 2 of period 2. Because K is 2 here. So AQ is equal to A, which is coming out as A. As we have seen, AB took this 1 minus 2 minus 6, minus 3, 2 and 9, 2, 0 and minus 3. So after multiplication, corresponding, respectively A into A into A, first A into A, whatever result comes out, then into A again. We have obtained A. It means it is a periodic matrix. So it is a periodic matrix of period 2, because in place of K we have taken 2 here, 2 plus 1. Okay, so A raised over 2 plus 1 is equal to A. This is periodic matrix. Okay, so periodic matrix is defined. Periodic matrix is a idempotent matrix if K is 1. In that case, it is the least value of K. But K is positive integer. So K is positive, then k can be least value, that means k is equal to 1. In that situation, this periodic matrix will be an idempotent matrix. Idempotent, but 13th one, when a square equal to a in that situation. Okay, now 15th, this is very important. This 15th and 16th I'll take in detail in the next lecture series, not at the moment. I'm just going to brief it at the moment, brief introduction of this. I'll take a very small example here, but number of questions based on this, number of questions have been asked by the students, so that I'll take in the next lecture series in detail. So please see my third lecture series, in which I'll discuss about adjoint of a matrix or multiplication. First I'll define multiplication of matrices and addition of so I'll take this in fourth lecture series. While in third one I'll take addition, multiplication, subtraction, etc. Subtraction of matrices, addition of matrices, what is the multiplication of matrices, all those properties of them, multiplication properties of multiplication of matrices. I'll take them with illustrative examples or with instances, I mean. Okay, so that I'll define in third lecture series. Multiplication and addition, subtraction of matrices I'll take in the third lecture series with questions, because questions have been asked by the student. That way cannot be miss them, because I have to solve those questions based on multiplication. Because multiplication is having some systematic calculation that should not be missed. If any step of this is missed, just like I calculated here a cube, okay, a into a into a. So if even a single step of this was mistaken, then answer would be wrong. In that situation, the questions are solved with the help of with systematic method, with patience. Otherwise, a minor mistake can result into a wrong answer. Okay, so that I'll take in the fourth lecture series. In the third I'll take multiplication. In the fourth I'll take adjoint of the matrix and inverse of the matrix. But let me brief them. What is adjoint of the matrix? Repeat one. Now adjoint of a matrix. For adjoint of a matrix we have to know about something. What is the minors and cofactors? Let me first define them. After that I'll define what is adjoint of a matrix. So for adjoint of the matrix we have to know about what is a minor of a matrix, and second I'll talk about what is cofactors, matrix of cofactors of a matrix, or cofactor matrix of cofactors. Okay. First let me define what is minor of a matrix. Okay. So minor of a matrix is, let me just take about it, is a determinant value of every element of a determinant, or every element of a matrix given, okay, is to be defined as the determinant of that number by leaving that number, or by removing that number from that, without that number, but leaving that row and column in which that number is lying. Then what is the leftover matrix in the given matrix, and that matrix is now we have to calculate, we have to find out determinant of that determinant. It is the determinant of a number of an element. Let me just find out what is minor here. First I have to define minor. What is minor here? Minor is the determinant. It is the determinant. In instance I'll take, it is the determinant of an element, or of an element of a matrix which is of that matrix which is obtained after removing or leaving, after removing the row and column of the matrix of that matrix in which that element lies, in which that element lies. What does that mean? Let me just take an instance. If a matrix A, let me say, it is 1, 2, 3, okay, 3, 2, 1, let me take 4, 5, 6. This is the matrix here. Now I have to find out minor of 1, the first element of this first row or first column. So how we have to find out? Leaving this, I mean removing this, without this row, first row and the first column, we have to remove them. So this remaining matrix 2, 1, 5, 6, it is now it is a square matrix here. So adjoint of a square matrix we have to find out. Adjoint of a square matrix. This is adjoint of a square matrix we have to find out. It must be a square matrix here. Adjoint of a square matrix. Okay. Now in case of this periodic matrix was also a square matrix. A square matrix, periodic matrix is a square matrix in which that was there. So square matrix, periodic matrix was also a square matrix. And in case of adjoint of a matrix, we have to find out adjoint of a matrix of a square matrix. Adjoint of a square matrix. It is adjoint of a square matrix we have to find out adjoint of a square matrix. But before that, what are the minors? Cofactors, let me define. Then I'll define what is adjoint of the matrix. But before that, what is the minor? The minor is the determinant of the minor of 1. Here I have to find out minor of 1. 1 is this 1. The element, minor of the element lying in first row and first column. Lying in first row and first column. Try to understand. And the first column. This one element, we have to find a minor of 1. So how we have to find out? We will find determinant of that number, which is obtained by finding the determinant of the remaining matrix. What is the remaining matrix? After leaving the row and column in which this element 1 is lying. The first row and the first column is eliminated, and then whatever is left, that means 2, 1, 5, 6 is left over. Now we have to find the determinant of this. Therefore, this is equal to determinant of 2, 1, 5, 6. Okay, this is equal to 2 into 6, that means 12. 2 into 6 minus, in between we put minus sign, 5 into 1. It is equal to 12 minus 5, that is 7. So minor of 1 is 7. Okay, minor of 1 is 7 here. You have to find out 7 value. Minor of 1, let me write here. Minor of 1, the first element, is equal to 7. This is value of minor here. Similarly, we can find 2. What is the minor of 2? Each element's minor can be calculated. How? That can be calculated by removing, not considering the row and column in which that element is lying. For example, if I find out what is the minor of 2, the second element of the first row, we have to leave this column and this row, first row. What is left over? 3, 1, 4, 6. This is 3 by 3 by square matrix. The minor of a square matrix we have to calculate in this case. So this is okay. So leaving first row and second column, what is that? 3, 1 and 4, 6. So the determinant of this we have to calculate that. So minor of 2 and let me take minor of 2 is equal to this 3, 6 are 18 minus 4 into 1. It is 4 here. It is equal to how much? 14. This is 14 here. to 14. Minor of 2 is 14. Similarly, minor of 6, if I have to find out. What is minor of 6? 3 here, sorry. Minor of 3, the third element of the first row, or the element lying in the third column. So we have to leave this third column in first row. Now left over the matrix is 3, 2, 4, 5. Determinant of this we have to calculate. How to find out determinant? 3, 5 is 15 minus 4 into 8, which is 7. Difference of, so minor of 3, let me write here. Minor of 3 is equal to 5, 3 are 15 minus 4 to the 8. This is a minor here, so it is 7. Now what is the cofactor then? This is minor. In this way we will determine minor. How to find out minor of the third 3 here in the second element, first element of the second row, 3 here. What we will do in this situation, minor we are still calculating. So minor of 3 here, which is the second element of second row, sorry, first element of second one. Sorry. So how we have to find out removing or not considering the second row now, because it's lying in the second row and first column. Whatever the 4 elements are left over, that we have to now consider. And this is 2, 3, 5, 6. Multiply the 6 to the 12 minus 15. So 12 minus 15 is minus 7. So minor of 3. Minor of 3 is minus 3. Minor of 3, which is in the second row, first element of second row. In this way we have to calculate minors. Okay, this minors, cofactors, everything in case of adjoint and inverse I'll discussing okay in detail, this number of illustrations. Okay, in case of fourth lecture I'll take this. Okay, so that please see. Now still just understand, because I have to define this here, adjoint of matrix. For that minor must be known to a person, and cofactor. What is the cofactor finally? The cofactor is obtained. Let me just find out what is cofactor then. This is minor and cofactor is what? What is the cofactor of an element here? Cofactor of an element Let me take matrix is here. Let me take A11, A12, A13, A21, A22, A23, etc. A31, A32, and A33. Suppose I have to find out again A11. Okay, minor of